If you want me to wear some more trash bins on my head, good morning fellow mathematicians, welcome back to another video. Back at differential equations once again, trying to get some progress in this series on differential equations, and today we are going to talk about linear non-homogeneous first order ordinary differential equations. I got to practice this word a lot, those words, because I'm re-recording this stuff so often, most of the time. Those videos are quite hard to make. Support me on Patreon if you appreciate me doing this series. So, proving this is quite easy because we have proven the homogeneous case the last time. So let's just dive right in. So this time we are talking about this case right here. Y prime equals to a times y plus some b. Those b's can be constant, they can be functions of t. We are dealing with them like they are functions of t today. And a and b are continuous and they are going to from some interval subset of the real numbers to the real numbers. And also, this right here, this differential equation satisfies the initial value problem y of x naught equals to some constant, which is element of the real numbers. And to this problem right here, there's a unique solution phi. It's differentiable, and also it's going from the same interval to the real numbers, and this phi is given by this long expression right here. And you might notice we have this phi naught right here, and this phi naught looks like this, and it looks a lot like the solution to the homogeneous case. And that's what we are going to work with today. As always, we are going to talk about existence at first and uniqueness in the end. So let's go ahead and start off with the existence. So to show the existence, we want to use something that's called variation of parameters. So if you take a closer look at the solution phi right here, you might notice something. So we have this first term right here, which is representing some homogeneous solution, some complementary solution to this problem. And then we are adding some new term to it. And this thing is called the particular solution. And in order for us to get this expression of phi, we are going to multiply this phi naught we are having with some new function in terms of x. We are going to call it u, and this thing is differentiable. So the first thing, we are going to say phi is nothing other than some phi naught that we are having times some u. And this u is, just like I said, differentiable and going from the same interval to the real numbers. And this technique right here, by assuming we can multiply it with some function of x or function of t, whatever you might want to call this parameter, that's variation of constants, variation of parameters. And I said it's differentiable, so why not differentiate both sides and see what we get? So that also means phi prime. What is that? That is phi naught u, but prime. And now we have to use the product rule because both functions are in terms of xt whatsoever. So we have phi naught prime times u at first, and also we have positive u prime times phi naught. And we have the definition of phi naught, and like I said in the beginning, phi naught is the solution to our homogeneous case. So if we take a look at phi naught, so this first term right here is nothing other than some phi naught times a in this case times u plus some u prime phi naught. And we are doing this under the assumption that this phi right here, just like the theorem states, is the solution to our non-homogeneous equation. So this right here is a phi plus some b, and those two are equal. But we know what phi is. Phi is nothing other than phi naught times u. So if we compare the coefficients, that thing right here is just this term. So that also means that our b is this term right here. So in order for this equation to hold true, we have a new condition. That also means that b must be equal to u prime times phi naught. that's the conclusion right here. And what we can do? Well, phi naught is strictly positive, so it's not equal to 0. That means we can invert it. So we can divide both sides by this term, and then we can integrate both sides with some upper and lower bound. So that also means we have u prime equals to, and now we have b over phi naught. And now integrating both sides with respect to t, dt, and from x naught to x, to make use of our initial values, from x naught to x, dt. What do we get? Well, the left-hand side, using the fundamental theorem of calculus, we end up with some u of x minus u of x naught. So at first we have u of x minus u of x naught. And that's basically it. So we can find out the value for our u of x if we would just know what u of x naught is. How can we find that out? Well, we could get information of u of x naught if you would plug in x naught into phi. So let's do this real quick. So that also means phi of x naught is just phi naught times u of x naught. We can use this argument on both functions, so we have phi naught of x naught times u of x naught. But what is phi naught of x naught? Why not find this out? Why not? Phi of x naught. So if we plug x naught into here, that's the integral from x naught to x, so that makes a 0. So that's the exponential function of 0. That's just a 1. So this thing right here is a 1. So that means we have phi of x naught equals to u of x naught. But our theorem states that this solution right here satisfies this initial value. Phi of x naught equals to c. So this right here is just a function, a constant c. So that means u of x naught is just c. And what we end up with is that u of x is nothing but c plus this integral from x naught to x of b over phi naught integrated with respect to t. And that's the existence, my boys, because we have shown that this phi indeed exists. It's a solution to our differential equation, and also our initial value exists, just like the theorem states. And now for the uniqueness. As always, for the uniqueness, we basically just want to show that we have a new solution psi to this problem. So let psi equals to phi naught times u in this case. And we want to show that we can express this psi right here always in this form. So that's our goal for now. And the good thing is, we have shown the uniqueness for the homogeneous case before in the last video. So the uniqueness of that thing is done. So all we really need to do is to show that u is also unique. So that means, let's suppose we are having a new psi which is constructed as some u naught times phi naught. And now we are just going to do the whole process over again that we just did. So that also means that psi naught is nothing other than phi naught prime u naught plus u naught prime phi naught. And just like before, this thing right here is supposed to be the solution to our non-homogeneous linear ODE. That also means that we have a psi plus b. Just like before, that thing right here is that, and also we need this term right here to be equal to b. So let's just do this. That also means that b is nothing other than u naught prime phi naught, and u naught just is differentiable once again. Phi naught isn't equal to 0, it's strictly positive, so that means dividing both sides through, integrating, what do we get? We know that we now have the integral from x naught to x of u naught prime integrated with respect to t is just u naught of x minus u naught of x naught. And this is equal to the integral from x naught to x of b over phi naught integrated with respect to t. Now our mission is to find out what u naught is. So let's just plug x naught once again into here, because since psi is supposed to be a solution to this differential equation, our initial values also need to hold. So that means psi of x naught equals to phi of x naught, phi naught of x naught, times u naught of x naught. But this thing right here is just c all in all, and also this is 1, just like we found out before. That also means that u naught of x naught is also c. So our conclusion is that u naught of x is just c plus the integral from x naught to x of b over phi naught integrated with respect to t. And this right here is indeed just u of x. And that's exactly what we wanted to show. That also means that this psi right here is phi naught times u. And that means we can express all new solution psi in this form right here. And then we are done. So that was a quickie, I guess. If you did enjoy this video, please like and subscribe and recommend me if you like. If you want me to wear some more trash bins on my head, then please take a look into the description. There will be a link to my Patreon. I'm doing all the stuff for free. It's a lot of effort. So I would highly appreciate it if you would like to support me a little bit. And up until the next video, have a trashy day. See ya.
2. Okay. Was hatte Micha gehabt? Entschuldigung.
2.